friends, welcome to the world of discrete mathematics with me Kunal Aire on my YouTube channel. Here we are going to discuss the concept related with discrete mathematics. In this session, again we are going to solve the examples related with mathematical induction. Now the first example, by method of induction, prove that 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial plus dot 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 n into n factorial is equal to n plus 1 factorial minus 1. So this is nothing but the p of n. So let p of n be a statement. What is the statement? That is 1 into 1 factorial plus 2 into 2 factorial plus dot 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 plus n into n factorial is equal to n plus 1 factorial minus 1. Now starting from the step number 1, that is basis of induction. क्या करना है हम लोगों को इस स्टेप में? That is prove for p of 1 means n is equal to 1. So therefore take LHS. So सीक्वेंस है तो LHS और RHS दोनों दिखाना है हम लोगों को यहाँ पे. n into n factorial is equal to 1 into 1 factorial. So 1 factorial का वैल्यू कितना रहता है? 1. So 1 into 1 we get a what equation number first. Now go for RHS. What is RHS? RHS is equal to n plus 1 factorial minus 1 is equal to n is equal to 1, 1 plus 1 factorial minus 1, 1 plus 1, 2 factorial minus 1, 2 factorial is equal to 2, 2 minus 1 is equal to 1, equation number second. Therefore from equation 1 and 2, LHS is equal to RHS. Therefore we said that P of 1 is true for n is equal to 1. Now step number 2. What is step number 2? That is induction step. Assume that, क्या करना है यहाँ पे हम लोगों को? Assume that P of k is true for some k belongs to capital N. Means 1 into 1 factorial plus 2 into 2 factorial plus dot 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 plus n is replaced by k. K into k factorial is equal to k plus 1 factorial minus 1. This is equation number third. Now again same concept. आपका ये equation third कहाँ पे यूज होने वाला है? For step number 3 के लिए induction hypothesis में. So step number third, induction hypothesis. That is we have to prove for p of k plus 1. So we get the new sequence, that is 1 into 1 factorial, 2 into 2 factorial plus dot 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 plus k into k factorial. Now this is a sequence, means we have to add one extra term, that is k plus 1 into k plus 1 factorial is equal to, now on RHS this is a constant term, so we get k plus 1 factorial minus 1. Now you have to show that LHS is equal to RHS. Now take LHS. LHS is equal to 1 into 1 factorial plus 2 into 2 factorial plus dot 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 plus n into n that is a k into k factorial plus k plus 1 factorial. यहाँ पे क्या होना चाहिए? That is k plus 1 into k plus 1 factorial. Now from this term 1 into 1 factorial to k into k factorial, this term, right? So ये equation आपका कौन सा है? That is nothing but the equation number 3. So from equation number 3, this term is equal to what? K plus 1 factorial minus 1. Put this value in equation number 3. So we get k plus 1 factorial minus 1 plus k plus 1 into k plus 1 factorial. Now from this term and from this term, take k plus 1 as a factorial, k plus 1 factorial as a common term. So within the bracket remaining value यहाँ पे क्या रहेगा 1, और then plus remaining value in the next bracket is k plus 1 and then minus 1, keep as it is. So here we get k plus 1 factorial into k plus 2 and minus 1. By using the concept of factorial, that is n factorial is equal to, we get n minus 1 factorial. Again we can write it as n minus 1 n minus 2 factorial and so on. So ये term भी हम लोगों का replace हो जाएगा, k plus 1 और k plus 2 है, that time it is replaced by k plus 2 factorial minus 1, equation number 4. Now RHS is equal to k plus 1 factorial minus 1. So we get k plus 2 factorial minus 1, equation number 5. Therefore, from equation, which equation? Equation number 4 and 5, LHS is equal to RHS. Therefore, P of K is true. Sorry, that is P of k plus 1. K plus 1 is a true. Therefore, by principle of mathematical induction, P of n is true for all n belongs to capital N. Now, next example, by method of induction, prove that n cube plus 2n is divisible by 3. मैंने ऑलरेडी आपको बताया डिविजिबल और मल्टीपल दोनों सेम मेथड से हम लोगों को सॉल्व करना है, दोनों का कंसेप्ट एक ही रहेगा. सो लेट P of n be a statement. What is the statement? That is n cube plus 2n is divisible by 3. Therefore, step number first. What is step number 1? That is basis of induction. So what is basis of induction? Prove for P of 1. Means n is equal to क्या put करना हम लोगों को 1 put करना है. So we get 1 cube plus 2 into 1. So we get 1 plus 2 is equal to 3. Equation number first. Therefore, from equation 1, 3 is divisible by 3. Right? Means P of 1 is a true. Therefore, P of 1 is true for n is equal to 1. Now go for the step number 2. Step number 2, that is induction step. What is induction step? Assume that P of k is true for sum k belongs to capital N. Means, again, what is the equation? That is n cube plus 2n. Means here we get k cube plus 2k is divisible by 3. Equation number second. Now step number 3rd. That is induction hypothesis. So therefore, we have to prove for P of k plus 1. Now जो इक्वेशन दिया, दिस इज अ कांस्टेंट टर्म. सो कांस्टेंट टर्म है तो हम लोगों को क्या करना है? रिप्लेस करना है. दैट इज वी हैव टू प्रूव फॉर k plus 1 ब्रैकेट क्यूब plus 2 within the bracket k plus 1. So is equal to, now a plus b bracket cube, that is a k cube plus 3k square plus 3k plus 1 cube plus multiply by 2. So we get 2k plus 2 is equal to k cube plus 3k square plus 3k plus 2k. So we get 5k, that is 3k plus 2k, and then plus 1 plus 2 is equal to 3. So what is equation number second? That is k cube plus 2k. So k cube और 2k हम लोगों को separate consideration करना है. So we get k cube plus 2k within the one bracket, right? From equation, which equation? ये कौन सा equation आने वाला आप लोगों का? Second equation, right? Then plus remaining values. What is the remaining values? Check out. So first one is 3k square, then second one is 3k, and the last one is 3. So here 3k square plus 3k plus 3. Now from this term, take 3 as a common term. So we get k cube plus 2k plus 3 take as a common term, k square plus k plus 1. Now multiple of what? Multiple of 3. So multiple of 3 means which is divisible by 3, and that is nothing but the equation number second, means step number 2, from step number 2. Therefore on RHS both terms are divisible by 3. Therefore P of k plus 1 is true. Therefore by principle of mathematical induction, P of n is true for n belongs to capital N. Now simple steps are there, 3 steps are there. First one, basis of induction. Second one is, that is basis of induction. Second one is induction step, and the third one is the induction hypothesis. Now next example, last example related with mathematical induction, that is n raised to 4 minus 4n square is divisible by 3. So again this is P of n. So let P of n be a statement. What is the statement? That is n raised to 4 minus 4n square is divisible by 3. But what is the condition? N greater than equal to 2 condition, right? So n का वैल्यू हम लोगों को फर्स्ट स्टेप जो करना है, बेसिस ऑफ इंडक्शन फॉर n इज इक्वल टू 2 के लिए. सो स्टेप नंबर 1, दैट इज बेसिस ऑफ induction. But here we have to consider P of n के लिए n is equal to what? 2. Therefore we get 2 raised to 4 minus 2 into 2 is equal to 2 raised to 4 is equal to what? 16. 16 minus, here we get 4, sorry that is not a 2, यहाँ पे क्या होना चाहिए आपका 4 रहेगा, ठीक है, 4 और ये square, right? So 4 into 2 square. So again here we get 16. So 16 minus 16 is equal to 0, which is divisible by what? 3. So 0 is divisible by 3, means P of 1, not a 1, that is a 2, is true for n is equal to 2. Now step 2, that is induction step. So क्या करना है यहाँ पे? Assume that P of k is true for some k belongs to capital N, means k raised to 4 minus 4k square is divisible by 3. And the last step, step number 3. Now consider this one as equation number first. Now step number 3, that is induction hypothesis, means prove for P of k plus 1. So here we have to prove that k plus 1 bracket raised to 4 minus 4 within the bracket k plus 1 bracket square. So again constant term है तो k is replaced by what? K plus 1. So k plus 1 bracket raised to 4 means we get k raised to 4 plus 4k cube plus 6k square plus 4k plus 1 minus 4 within the bracket. Now k plus 1 bracket square. So k plus 1 bracket square is equal to k square plus 2k plus 1. Now here we get k raised to 4 plus 4k cube plus 6k square plus 4k plus 1, then multiply by 4, so we get 4k square minus 8k, then minus 4. So is equal to, here we get k raised to 4 plus 4k cube, then plus 6k square plus 4k and minus 8k, okay, then minus 4k square and then minus 3. So is equal to, now we can write from equation number, step number 2, that is equation number 2, k raised to 4 minus 4k, that is 4k square as a separate term. Then remaining values plus 4k cube plus 6k square, then minus 4k, and the last term is a minus 3, is equal to, make the adjustment. So k raised to 4 minus 4k square bracket complete plus 4k cube plus 8k plus 6k square minus 12k, and the last term is a minus 3. यहाँ पे adjustment क्या है? minus 12 और plus 4 means we get a minus 4k plus 8k or minus 12k we get a 4k. So here we get last term as a k raised to 4 minus 4k square bracket complete plus, now from this term and this term take 4 as a common term, so we get 4 within the bracket k cube plus 2k bracket complete plus, now from this term take 3 as a common term, so we get as 2k square minus 4k and then minus 1. So which is multiple of what? Which is multiple of 3 means divisible by 3. Now that is nothing but the equation number, ये कौन सा equation है आपका? From, that is the step number 2 means equation from equation 2. Now this is also divisible by 3 because if we put k is equal to 1, so again we get 3. If we put k is equal to 2, अगर 2 हम लोग put करें तो we get 2 cube plus 2 into 2, so we get 8 plus 4 is equal to 12. So which is divisible by again 3, right? So on RHS all the terms are divisible by what? Therefore on RHS all terms are divisible by 3, are divisible by 3. Therefore P of k plus 1 is true. So by principle of mathematical induction, P of n is true for all n belongs to capital N. In next lecture, we'll start the new chapter, that is mathematical logic. If you like my video, then like it, share it and subscribe to my channel. If you want more videos related with the discrete mathematics, then don't forget to click on bell icon button.